Hello, I'm Paul Phillips. I gave a variation of this talk last night, and the audience looked like shell-shocked. Genuinely, they looked like they'd been through a war, and I realized. So I think I'm going to tone it down tonight. Yeah, no, you're all disappointed. I think one of those a week is probably good. You got to come to. If I'm going to do back-to-back nights, you got to come to the first one if you want the exciting stuff. So I'm going to be all chill tonight. But on the other hand, I'll probably not actually be able to hold to that, but I'll try. Yeah, so my slides, I'll just tell you up front, are pretty bad. They're all over the place. I don't know what's going on. We're just going to have to live with think of it as one of those non-linear narratives, like Quentin Tarantino movie or something. So suddenly something happens late that isn't that, yeah, okay, so it's non-linear. But, so we have this little stable of maybe 10 programming quotes that get recycled indefinitely, and this is one of them. But it's good, and I'm going to read it. When I'm working on a problem, I never think about beauty. I think only how to solve the problem. But when I have finished, if the solution is not beautiful, I know it is wrong. This is always on my mind, especially when I see stuff like this. At this point, I feel like anybody would know we're doing it wrong. But that thought process has to take place. You got to say, wait a minute, are we doing it wrong? Well, yes, you're doing it wrong. This trait, this is pure boilerplate. It has no purpose in life except trying to pass all those type parameters around. It is a true monstrosity. It has dozens of buddies spread out throughout the collections. It accomplishes essentially nothing. It's the base. This is parseq view-like, so it was views. It's views parallel. I don't know. It's like a bunch of stuff, and then you've got all these variations on the same. Those are all just trying to keep track of what the type of this thing is, and so that subclasses can figure it out. Anyway, this is not right. This is not beautiful. This will never be beautiful, and this is impossible to maintain. This is not how you do views. And so now I'll tell you who I am. So I guess most of you know me, unless you're brand new to Scala, but I always have to assume there's somebody in the room who doesn't know me. I wasted about half of my last decade, slightly more, on Scala. That's a little unfair. I didn't waste it. I learned some stuff. But in the end, it's a failure. I had to quit because I can't make Scala do what I want. And so I'm going to try something else. But I worked really hard on Scala, and I wrote a lot of code, a crazy amount of code, and I drew a lot of conclusions, which I guess you will hear now. But yeah, I quit, and it really was a dream job. Typesafe was like a fantastic place to work, and they didn't say I had to do anything terrible, and I could, basically do what I wanted, and I quit because I was just, Scala is never going to be the language I want. And I know you guys are sitting here going, wait a minute, this is supposed to be the pro Scala thing, and I'm not anti-Scala, I'm just not exactly pro-Scala. At least I'm not pro on the inside anymore. More of an observer. But this is to show you why you should care, because that bonfire right there is me. And that's about 1 million lines of code on GitHub, and that's just the tip of the iceberg. I've written at least 3 million lines of Scala code, at least. Yeah, I should spend a lot more time designing, to be honest. That's what you should really learn from that. But it does mean that I every sort of idiosyncratic thing, the kind of observation that you have to log an enormous amount of time to really see, I have all those in my head. So that's where my information comes from. And then here's my other credential: 891 tickets closed. Mostly those are bugs fixed. 482 tickets opened. Mostly those are won't fix, things that I wanted to do and got won't fixed. I don't know about mostly, but plenty of them are. 150 of them I think are maybe still open. But I've personally discovered in the neighborhood of 500 Scala bugs. Discovered and reported. I've actually stopped reporting them, so I've discovered more. Have you discovered 500 Scala bugs? Some days I can't believe the things I just, nobody's ever encountered this before. Do you guys report bugs? I don't know. But one way or another, I got 500 on my name. And so, yeah, anyway, the point is that you have to listen to me. You don't have a choice. It doesn't matter what you think of me. I know something It's impossible for me not to have, osmotically acquired some knowledge about Scala in the course of doing this. But yeah, the difficulty for me here, I have no problem speaking my mind, as is probably apparent from the things I've written online. But I don't want to be standing here ragging on Scala all day for both personal, professional, and just general not being seen as a giant jerk reasons. It's very natural and easy for me to do so, but that's not what I want to do. And because I did plenty of that last night, I'm going to try not to do it too much tonight. But you can always prod me with questions, and I'm sure you can get me going. So, is Scala too complex? This question goes around sometimes. You hear this, you hear that. Let me simplify. Yes. There's just no question. I think, to me, it's what are you guys talking about? I mean, these sort of imaginary metrics about what complicated means are thrown around. No, complex, you know it when you see it. It's like obscenity. And if you program in Scala, you know it. And if you try to use Scala in any way that pushes the implementation, you really know it. So, I mean, I don't see how this is really an arguable point. And I can't tell you how often people tell me that they don't report bugs because they don't know if it's a bug. I'd say that's a good litmus test for complex. People can't even tell when they see something happening whether it's supposed to happen. Something is complicated somewhere, right? I mean, they're not all in way over their head, and I include myself in that group for sure. It happens all the time. Is this a bug? I don't know. We have to go debate it. So this meme goes around. It's too complex. Well, so these are my ideas about what one might do in the face of that, assuming it's a problem. We can own it, say, all right, yeah, it's complex. We're dealing with complex stuff, and it's a complex implementation. Eat it or go do something else if you don't like it. We try to make it less complex. That'd be a reasonable thing, too. Look at us. We're making it less complex. Or we could try to obscure it. We could leave it complex, but maybe if they don't see it, then we're in good shape. As you can surely surmise from the lead-in, we went with option C, as we will see now in detail. The use case. The use case is emblematic of why I don't work on Scala anymore. So the use case is what I've just described. It's too complicated. People say it's too complicated. Let's just not let them see that complicated thing. So here's the result. Look at the signature of map. What's wrong with this picture? You guys ever seen what a map actually looks like? It's got two type parameters. It's got a key type parameter and a value type parameter. We sell this as the signature map. Here it is, A to B, and you get a map B, whatever that is. I don't have a clue. That's the official documentation. This isn't some fringe thing. But fortunately, you can expand it and then see the full signature, which is also a lie. It conflates the B-type parameter from the enclosing class with the B-type parameter that comes in. There's no indication whatsoever that this is totally wrong and that's totally wrong anywhere. This is the official documentation. It's outrageous. So you're thinking, well, it's a bug. It's something recent. They'll fix it any day now. I'll come back to that in a minute because I got to do this slide, I guess. This is what you actually have to do to see the proper signature of map, and it's here, where you can see a K, a V, a B, and a that. The outer B has been renamed for clarity here, which is the point, that you need to know the difference between what's coming in and what's going out when you call map. This is the earliest ticket I could find that brings this up. I think it's clear from the problem description in the ticket that it's talking about exactly the same thing. Obviously, map B doesn't exist. Well, yeah, obviously map B doesn't exist, but 44 months later, that's still the official documentation. So, as I say, your time has no value. That is the message I would get from somebody who in 4 years cannot be troubled to change the documentation to remotely reflect reality. Excuse me. Amazing effect there with the little jiggling 44 months. 44 months, but that's a long time, right? This is the evidence. It's a screenshot. You're going to have to take my word for it that that's 2014. I don't know. But anyway, there it is. That's the nightly documentation from January 14th. So unless they fixed it in the last 5 minutes, it's still there. And so it's this sort of like callous indifference to the impact that this has that drives me nuts. As a person who reads the documentation, you might think that's true, but you can't trust it. And it's intentional that you can't trust it. That's, if something's complicated, you got to live with it, right? I mean, it is. It's complicated. It doesn't go away by pretending it isn't. And the impact of trying to hide it is going to be really far-reaching. It's going to extend through a bunch of stuff. So why is there something to hide at all? Well, here we are looking at it. So we've got map, and we've got map. So because what map, in quotes, is bringing to the table, and this is what happened, and this is where things really started going wrong in the collections, is it took this beautiful, pure abstraction, like absolute beauty for reasoning, and you name it. It's like one of the monadic foundation. I mean, everything about it is great. And it put this thing on it. Implicit builder can build from 3-type parameter nightmare. Right? Nothing will ever be beautiful again. It's this guy, right? I mean, it's like it should be called Gollum. Ryan Gosling, I'm sure everybody will agree, very handsome man. Not Gollum. So why? Why was this done? We must be getting something great out of this, right? So we're getting what I call the Bitset Gimmick. The Bitset Gimmick is that you can take a bit set and call map on it, and if you map to ints, you get a bit set back. But if you map to something that you can't make a bit set out of, then you'll get a lesser type back, like a set. That's pretty cool. Great, wonderful. Look, there it is, working correctly. Now, just come at it from any angle at all, or just tweak it or look at it funny, and it doesn't work, right? For instance, take the very same operation, the first map, and do it in 2 maps. Now, taking a collection and calling map F, map G should be the same as calling map F and then G. And that's long gone, because the intermediate call has a whole type inference stage. A can build from comes in, does a bunch of stuff invisibly, and makes it impossible to reason about anything. So there's a good example of what happens. In the one case, you've got a bit set, and in the other case, you get back a sorted set. And then here we are just map identity, right? I mean, something map identity is supposed to be something. That's kind of what identity means. But here we are, something map identity, and try to get the 1 out. Hey, wait a minute, it doesn't even compile anymore. Can build from, what's that? Nobody told me about can build from. I saw the signature of map, it's A to B. Similarly, and this is pervasive throughout the collections, there are these qualities that may or may not be in a collection and that may or may not persist. So you've got a sorted set and you do something to it. You map it, you filter it, you reverse it. I don't know, I guess you can't reverse a set. Doesn't matter. You do something. Is it still sorted when it comes out the other end? Who knows, right? Roll the dice. And here we see some of these sicker sort of things. This is essentially the same problem yet again, in that doing something as a series of steps gets you a different result. In this case, not just a different type, but because it's a different type, a different thing. Those aren't the same numbers I'm looking at. I mean, they are the same numbers, but they're not in the same order because they're not sorted. And the third thing and the fourth thing here, if it's not obvious, are the same thing. It's only the number of times I called map that's different. There's this idea that you should be able to, in a programming language, you should be able to take a sub-expression and assign it to a variable, use the variable in place of the sub-expression, and get the same result. This is just a key, it's a foundation of reasoning. Now, even without these issues, we wouldn't be able to do that in Scala, but this makes it, impossible. And if that's, not bad enough, we've thrown out what should be these invariants, if you call map, you get out the same number of things that you put in. This is a, This is the invariant of map. This is what map is. But instead, we have this idea that, it's more important that a set be a set and that you get to map a set and get a set back than that map, excuse me, than that map can do what it's designed to do. So instead, we just throw stuff away on the back end of map if they happen to collide. So here you've got a set with 3 things in it, and you call map, and that first map, they all map to 3. So whoop, there's only one thing after that because they all just got thrown away. Then we call G, and there's one thing. Here we do it all at once, and then it never gets a chance to get in the middle and make it disappear. So again, now we have a different size set. If you cannot reason about code, you cannot write correct code. It's literally impossible to call Scala's map from Java. If you were going to design a collections library and Java Interop was like one of the bases on which you sold your language, which is certainly true of Scala, I would think that you would do it with Java firmly in mind. But we've literally made it impossible to call into Scala. It's can build from, here it is. I played with it until it got too tedious. This is in response, all the details are at that ticket. This is in response to my ticket years ago saying we literally cannot call from map. And it turned out to be true. Well, at least neither Martin nor I could. I mean, if you want to show us some of your stuff, maybe you can figure out how to do it. The variances of can build from cannot be modeled in Java. Java doesn't even let me override it with a cast, so you can't do it because Java's broken. So this is like a common theme when stuff doesn't work. Blame Java. Just a moment. All right, now that I got this nice and wet. All right, are we back? Are you guys happy to hear that this is the version where I don't spend a lot of time ragging on Scala? I'm actually trying to race through it so I can get to the part where I don't. But I don't know. I'll be honest with you. I'm emotional about this. I invested a huge amount of my life into this language. And now I have to leave because nothing good happens. That frustrates me, and it's going to be apparent. What can I say? Won't fix. Indeed, it won't fix. So now I'm just going to do the laundry list here of stuff. More stuff that it does wrong or that it does, in a way that causes trouble. So the collections in general and actually everything in Scala, the implementation details are never separated from the interface. And so and I'll have examples of this in a moment, but there's not even an attempt to say that here's an abstract model of how the thing works and here's the implementation. It's just a blob. And it evolves like a blob, and it's always a blob. The collections have 556 explicit casts as counted by grep. That's just the explicit ones. That doesn't count all the pattern matches to pattern match casts, because you can blindly cast by way of a pattern match easily enough. So there's probably another 1,000. So here we are at the world's most complicated type system, as people think from some distance, and we can't write a collections library that doesn't have thousands of casts in it. That's kind of nuts. Casts are just the beginning, though, because we suppress variance checks all over the place because it's unsound. So we have to suppress variance checks to support the model. So, of course, all this stuff adds up to, various forms of unsoundness, many of which exist. There's at least a dozen. Specificity rules are, I'll show you that by example because I don't want to explain it. This one is something probably not on your radar, but it's going to be gigantic because of the way that implicit selection and type inference are codependent. I mean that in the clinical sense. Because of the way they're codependent, they affect each other in such a way that they are becoming impossible to change. And because nobody knows actually what happens in type inference, it's an experimental science with Scala C. All you can do is throw particles at it and watch them bounce, see if they go through the 2 slits. Because of this, fixing bugs is crazily difficult. You generally break things that you can't even see because it is some corner that you haven't tested yet, but people will discover it for you and report it as a regression 6 months down the line. That situation will eventually just freeze the entire thing in place. In the collections, inheritance of implementation is essentially the hammer for all purpose. But like tragically, nobody had discovered final or private when most of these were being written. So all that stuff is out there in the world. It's impossible to maintain correctness in an inheritance-oriented language when you have methods doing stuff that depend on the other methods, and they can be overridden selectively. It's literally impossible to maintain correctness. So deprecated non-final annotation had to be invented for the purpose of 2 years from now, after another release cycle, we can start finalizing these methods. Of course, I don't think that I'll still be giving these talks at that point. I won't be getting invitations anymore. This is just an example of many, many, many possible examples. Things that, if you don't nail them down up front, burn you terribly. It's really important to be able to make optimizations like that. Or for instance, if I take a giant set and another giant set, or a giant set and an empty set, and I'll add, am I allowed to return the original set? If you don't specify these things up front, then people will just start depending on whatever it happens to do. And surely that's what's happened here. So people can do a reference equality check on the return of this, and that means since it says it's a new collection, it has to create it. So if you take some billion element list and filter it so that you just get it back, you still have to make a new billion element list. These are not small things. These are giant things. But because they're not, nobody's taken the trouble to nail down these semantics, you get the worst of both worlds. As the user of it, you have to assume the worst. As the compiler developer, you cannot make any optimizations. Variance again. Covariance. Do you guys ever think about what covariance really implies? If you have a covariant thing, or a contravariant thing for that matter, if variance is in play, it's essentially just an opportunity to not have errors. It'll find a way to make it work. Why are we using types if we wanted to find a way to make it work? Generally, that's not what we're looking for the compiler to do. Don't try to find a way. Actually, just see if you can do what I asked you to do in a sort of a direct way rather than ambitiously looking. So, for instance, this. I've got a list of ints and a list of doubles, as it turns out, and I put them together, and I get a list of anyval. Truly the world's most useless type, anyval. It is literally useless. If you ever wrote anyval intentionally in a signature, you would be nuts. I say, what are you doing? Is it some kind of joke? And yet we'll happily infer it and say, hey, no problem, that must have been what you meant. Is the purpose some devotion to some idea of generality, or is it to be useful? I really wish that the purpose was to be useful. This is what my list does. How does my list accomplish this magic? By being invariant. Oh, well, that sounds bad. That's Java, right? Their stuff's invariant. They don't get any fun. You can't, a list of apples isn't a list of fruits. That sucks. Well, you get the best of both worlds. You have a supertype that has everything except the things that cannot exist in covariance. And if you want, you can gladly, your PSP list can just fall back to the next type up. In the case of list, it would be seq, for instance. So you would say, well, it's a covariant sequence, but it's an invariant leaf class. And contained doesn't arrive until the leaf class, and you're done. It's type safe, and it's covariant. So it's inference plus variance that is at the root of many puzzlers and just nuttiness. The fact that there are these implicits sitting around waiting in the wings to say, here's something for you that you're not at all what you were thinking of. Because when you take something like can build from, all three type parameters of can build from are variant. 2 of them are contravariant, 1 is covariant. And so there's a classic bug involving fallback string can build from, which is a low priority implicit hiding in predef. But because 2 of the type parameters are contravariant, you could be asking for some super specific thing involving lists, doubles, and and it's just going to dial the variance up as far as it has to for it to match. So eventually it gets to any and says, here you go, fallback string can build from. That's what you wanted. What? It's nuts. This is what I mean about the variance rules rendering contravariance useless. Now, please take a moment to look at what's happening in this slide so that you can tell me that I'm nuts. because I essentially have probably put 100 hours into this one, trying to convince that this is not the useful definition of specificity. On the second line, I'm declaring there are two implicits. There's an ORed any, and there's an ORed list double. That means that the second one takes list double as its parameters. The first one will take anything as its parameters. Now I ask implicitly for a list double ORed, and I get the any. The reason is that in the same way that when something is covariant, it goes looking for the deepest subtype. When it's contravariant, it goes looking for the shallowest one, which is invariably any. But that's not what I want, right? You can't subtype upward. You can't subclass upward, right? The only way to write things and to actually extend existing things is to go downward. When you ask for this, there is no chance in the world that you're thinking, well, if there's an ORed any, that's the one I really want, not the ORed list double. It's nuts. And yet in 5 years, I couldn't convince the powers that be of this. And it's, again, that's among the reasons I've just abandoned the effort. So one of the true boondoggles in terms of correctness in the collections is the abstracting over mutability and immutability. This in hindsight, I say in hindsight because I did not properly understand at the time how bad it was. Yeah, it's a nightmare. You just don't want your mutable collections to have all the operations that your immutable collections do. It's a terrible idea. That you shouldn't be doing that with your mutable collections. You shouldn't be like, yeah, I'm just passing it around and we'll call, filter and da-da-da. No, you should be squirreling your mutable things into little tiny zones and making them sit there in highly controlled circumstances. And then maybe if you want to let them out, you to-list them or something and get the immutable one. And that's what you deal with. But your code, if you like correctness, if it's an interesting thing for you to pursue, you should not be treating mutable things as just like immutable with fewer letters. It's not an abstraction that you can do. So drop is a very fine example here. Say you've got a long list of 1,000 ints, and somebody comes in and says, drop 100. Well, so if it's a mutable thing, I can't give you back the back of my mutable thing. Or now there's two guys, each of whom think they have their own mutable thing. So I have to copy it. There's no choice. But if it's immutable, I cannot copy it. The only reason that immutable collections are acceptably performant is that kind of sharing. So one of them is wrong by definition, always. And that's the case in a bunch of methods. When you have to override constantly to avoid the wrong method in the guy above you, that's a sign you're doing it wrong. So in the triumph of code reuse, we have 24 concrete implementations of slice. Slice is not chosen to cherry pick a bad example, it's just a typical one. And in fact, it's one that I reduced the count dramatically a couple of years ago. This is the current situation. It climbed all the way back to where it was, 24. How is it possible that there are 24 ways to write slice? Can you even think of 24 ways to write slice? I mean, if I made it like I put a gun to your head, I want to see 24 interestingly different ways to write slice. I defy you to do it. So there's some classics up here. List 1, 2, 3 to set false. Do you know what's going on? I mean, if you've seen it before, you do. If you haven't, you might think, what? Would somebody like to share what's going on? All right, so Scala will happily just insert a unit if it thinks that's what you would, if it's like, what do I do? Oh, a unit would make this work? Then do it. Give them a unit. So you call it toSet, and toSet doesn't actually take any thing. It doesn't take any parens. And so because you gave them, it thinks you're calling it on the result of the toSet. So you actually are now calling the apply on the resulting set. And then it says, oh, well, that takes an argument. Well, oh, look, it's a set of any, because we inferred that because list is covariant. So this is a list of int, but it's going to, when it infers the type for the toSet, it's like, it's a list of any. Hey, it works. So then it's got a set of any, and it doesn't have unit in it, and so false. There's no unit in a set any of 1, 2, 3. There's no type error in there. Think of the chain of events there. That's like HAL 9000 going mad, saying like, well, if I follow this chain of reasoning, like a series of craziness, then I should just evacuate the airlock and, send them all out into space. There's no way you want to do any of that stuff. What's the next one? Another favorite. How can that be? How can that be? So Scala decided that whatever Java does is good, and we have to do it also, even if it's wrong. And in this case, that means if something takes a float, then give them a float, even if we wrote an int and the int doesn't fit in the float. And if round happens to only work on floats and doubles and not ints, then we'll just round that down to whatever, and then there we are with what's left, which isn't the same thing we started with. By the classical definition of round, I'm not a mathematician, but by the classical definition of round, that would not be the answer. Again, no error there. I mean, really, it's 2014, and here we are, and we cannot make the compiler in the world's most typed language tell us that a list of strictly integers does not contain your mom. I think there's something wrong with that. That's not entirely Scala's fault. That's like the laws of variance to some extent. But it is, and it's our fault for putting up with something so ridiculous that we cannot find a way to make that an error. It's nuts. We're no good at this if we can't do that, frankly. It's like, well, we should give up. Another favorite, there's no actual call to sum here, but this is the set thing again. And this is an actual bug that we had in the collections for a while. The way a set's hash code is calculated is by adding up the hash codes of its elements. Okay, here's the obvious implementation. Take myself, map to hash code sum. Great, it works, mostly. And then sometimes it's wrong. Oh no, it's the worst kind of bug because it's not that obvious. It just burns you when people show up saying like, well, one time out of 100, the thing disappears on me. Turns out that if two things have the same hash code, you're only going to get one. Because when you mapped your set, you got a set of hash codes, and only the unique ones survive. Now you sum that. And remember, this is, for emphasis, you might not even know it's a set. Here, this sum here is written to work on iterable. Certainly seems reasonable to do it on iterable. Your set never crosses your mind. But then the user of it, of course, might call it with a set, and you lose. Sets. So this is where we get into implementation details have infested, and implementation details and just ill-considered sort of like, let's just do it the first way that comes to mind, have infested the interface to the great detriment of the overall usability. These are the ways from a distance, forget about Scala, that one might sensibly define a set. In each case, there's one method. There's one that's defined in terms of the qualities of the things in the set. That's an intentional set. There's one that is the actual members of the set. That's an extensional set. In the one case, it's essentially just a predicate. Anything that matches the predicate, that's the set. In the other case, it's an iterable or some variation of that, something that allows you to enumerate the members of the set. Both of these are very useful things. They're very different things. They're not the same thing. They have totally different qualities. They have to be considered separately. Now, this is the actual interface of set, as can be seen by attempting to make a concrete class that extends set and seeing what isn't implemented. So here, we have both of those kinds of sets coming together, and now you see why set has to be invariant. Because intentional sets have to be contravariant, and extensional sets have to be covariant, and if you mix them together, there's only invariance left. And then you have these two hangers-on that I end up implementing with dummies half the time. Because why? Because somebody thought we need to have minus and plus on set. I don't know. For whatever reason, you don't have to do that on sequence, There's no rhyme or reason to it. It only requires one method to define a set. Everything else is something else. It is not the definition of a set. Maybe it's the definition of a growable, shrinkable set, right? I don't know. You shouldn't be cannibalizing bits out of other things and putting them on set. Set can be defined with one thing. Purity is not a priority, a purity of interface, but purity is actually how you actually have reusable abstractions. Size. Size is one of the worst. So size is on everything, always. You can't avoid size. Size is mandated. You have to have a size, and it has to be an int. So if you're infinite, forget it. You've got to make something up. Or just don't terminate. I don't know. Throw an exception. If size is extremely expensive to compute, like it's ON, like it is for list, doesn't matter. You still have to have a size right there and just make it available for everybody. You just no protection from anybody calling that. Just, eat it. There's no reason size should be assumed to be universally available and universally an int. And you don't gain anything from it either. There's no benefit. It's not like there's no convenience. If you need size to be universally available, you can easily implicit your way to all these bad, wrong answers if that's if that's your thing. But you don't need it to be, but once it's on the core types, there's no avoiding it. All right, I think I'm at the end of slagging on Scala. Let's hope. Let's hope. I know you'll get me going again in the questions. So here we have just a few things that one might do. So most of the things in here are real. I wrote them already. They're simple. They're not like fully fleshed out. They're just they're illustrations, because I often hear people say like, well, I understand that all of the complexity of the Scala collections is necessary to accomplish these things, but they sound like abused people, honestly. I mean, when they talk like that, it's true. Don't blame yourself. If it seems really complicated, more so than necessary, trust your intuition. These things can be done far more simply. This is not intended for you to digest in its entirety, but it's an example of the kind of thing that doesn't exist in Scala, which is to say an abstract model of the thing being implemented. You need this in order to have a check on what it is that you're doing, in order to have something that tells other people what it is that you're doing. If you have an abstract interface, the level of abstraction is negotiable, but the existence is not. This is just defining like some names for types and giving them sensible, like brief names, defining what they are, nothing else. There's no code here other than, types. But with this, you have a tremendous head start on actually like knowing what you're doing and creating something that's going to continue to do what it is that you think that it does in such a way that other people can see what it does. So in the collections, there are mutable and immutable collections. There is a division into sequence, set, and map. The whole thing got doubled with parallel collections. So there's parallel and sequential. And then everything's got a view and a regular. Now, all of that is like simplification because, in fact, there's like exceptions and special cases all over the place. But in principle, that means there would be 24 combinations in there, right? So there's like immutable, sequential, sequence view, right? And a lot of those do exist, parseq view, etc. That's a lot of freaking code, these 24 combinations. As I see it, you need one out of those 24. A set is a sequence without duplicates. That's all that it is. That's an extensional set. A map is a set with a buddy. That buddy is an apply that takes a set, which has the qualities of map keys, and turns them into values. Now you have a map. Once you have that, you're done. You don't need to have a bunch of variation, different things, incorporate tuples into, you don't need all this nuttiness that exists. Mutable collections, forget it. Write your own mutable collections. Problem solved, because you shouldn't have mutable collections in here. Parallel collections, problem solved. We can't get sequential ones right. We'll never get parallel collections right. I mean, it's comical. It's so hard to get parallel stuff right. These trivial things are not right. Forget it. So no parallel collections, problem solved. And views are what should always happen, because if you're programming immutably and sensibly, then you are glad for it to be behaving lazily in these situations. So you're done. You want seek view, immutable seek view, sequential. And then everything else is an add-on. And then suddenly I have 4% of the code to write that the main collections do. Size. So that's the problem with size in a nutshell. Maybe it's constant time. Maybe it's linear. Maybe I will never see that return ever. I don't know. There's no way to know. But I do know that if I have a thing that will never return on a call to size, it'd be better if it just didn't have the method, right? It's like if something's going to shoot random fireballs at you, maybe we could just not have the shoot random fireballs method. So this is what I came up with in order to make some sense out of size. The reason that size has all these bad behaviors is that things have to either lie or tell something they don't know, and they might have to work very hard to find out the thing that they don't know. So don't ask a question that requires them either to lie or to do really hard work. Ask them something they know. When you ask them, and that means, like everything in computer science, adding a layer of indirection. I'm not going to ask you what your size is. I'm going to ask you what you know about your size. Now, if you know your exact size, that's great. Tell me. I'll take it. I'll use that info. That's constant time. If you're infinite, tell me that. I'll take it. That's also constant time. And if you know very little, possibly nothing at all, because bounded can be 0 to infinity, then tell me that. Also constant time. So it's going to be constant time. You're never going to lie to me, and you're never going to be running off into la-la land, and now I can do something with that. Here's an example of how that works. Infinite. Look, I have defeated the laws of reality. An infinite collection told me its size. It's infinite. So there's logic in there that does things like if you call take 10,000 on an infinite collection, the size is going to be 10,000. Easy. You call map on it, since we don't just throw away duplicates at random, it's still going to be 10,000. We still know the size, and we've burned about 3 CPU cycles at this point. And we haven't done anything yet. That's the thing. This is an infinite collection with 2 operations having been applied, and nothing, no work whatsoever has been done. I guess this is, I was still screwing around with my slides, so we can see here. Redundant. We already did contains, right? Yeah. Aha. This is the best I could get anything to do in Scala with this operation. I have them by 2 orders of magnitude up there. What it's doing is taking essentially the range from 1 to 1,000,000, mapping it 3 times, dropping the first 999,999 elements, and then summing the last one. There's nothing in Scala that allows for this to do what it should do, which is to say, just index into the last one and add 3, right? The operator, when you do this, what you want to happen is go straight to the last element, add 1, add 1, add 1, done. That's what that does. This one builds all the intermediate collections. Why? Well, remember the signature of map? It insists on a builder, and there's no way to defer it. So map is going to sit there building the intermediate collections. Best case, it will build optimized range-like things. But far more likely, it actually has to build a 1,000,000 element collection 3 times to go for the last one. So that's 1,000,000 times more work than necessary. I'm sorry that only 2 orders of magnitude are apparent in the time. That's probably just measurement error. It's more like 1.427 microseconds, not milliseconds. And then the great tragedy of all of it is that it was totally unnecessary, because even if you love the Bitset Gimmick, you don't need to pollute map. And here is an illustration of it. There's a string. I map to an int and back to char. In Scala, the regular one, you get a vector of char at that point, for obvious reasons at this point. I get a string back. Why? Because I didn't insist on building it here. I waited. And the same element type came out as went in, and that's all that I need to build the same thing. And map has a signature, the beautiful A to B, the Ryan Gosling signature, not the Gollum signature. The builder comes in here. This can be implicit if you are so inclined. I don't think that's wise, but if that's the deal breaker, since I know small things are always like, oh, well, that's still really important that I don't have to force it somehow. Okay, fine, that can be implicit. in which case all of this looks exactly like this, except that it works. So we beat the Bitset Gimmick without ruining map. That's my last slide. So I can talk up here for about Scala stuff as long as you want, but they wanted me to leave time for questions, so I guess I did. You guys don't look quite as shell-shocked as last night, but still pretty good.